Section 7.2.39. The number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed with mean 1,260 and standard deviation of 129 chips. In Part A, it says, what is the probability that a randomly selected bag contains between 1,000 and 1,400 chocolate chips? So what we want to do is we want to be able to calculate, okay, the probability that X is going to be in between 1,000 and 1,400. Okay, so this is what we want to do. And so before we do anything, we need to be able to draw the normal curve and then shade the desired area region. Okay, so if we take a look at our graph, okay, we're going to draw our bell curve. So here's our bell curve. We know that our mean from the question above is 1,260. So that is 1,260. And so we want to find the values that are in between, well, 1,000. So if this is 1,000 here, and we know that we want to also find 1,400, and we want to find the shaded region, the area of the shaded region. So what we want to do is we first want to find the z-score. So we're going to use the formula for the z-score, which is equal to x minus mu over the standard deviation. So the first one we're going to look for is when it is equal to 1,000. So we're going to find the z-score, so we're going to let x equal 1,000. We're going to subtract the mean, which is 1,260. And we're going to divide by the standard deviation, which is 129. So if we take 1,000 minus 1,260 and divide that by 129 and round it, we end up getting a z-score of negative 2.02. Okay, now we also need to find the z-score for when it is equal to 1,400. So again, using the same formula, z is equal to x minus mu over the standard deviation. We have z, which is equal to 1,400 minus 1,260. And we're going to divide that by 129. And so z is going to equal, we're rounding it to 2 decimal places, is going to equal 1.09. So now this probability now becomes negative 2.02, which is less than or equal to x, which is less than or equal to 1.09. So let's draw this particular graph so we know what that looks like. Okay, so now this graph now becomes the following. We now have a mean of 0 because we convert into z-scores. Now it becomes the standard normal curve. And so the z-score for 1,000 is now going to be negative 2.02. And the z-score for 1,400 is going to be 1.09. And so what we want to find is the area, again, that's in between these two. Okay, so if we want to be able to use the table, okay, if we want to use the table, then what we're going to have to do is we first need to find the area to the left of the first z-score. So we're going to call this z-score 1, okay? So we want to find the probability of z1 where it is less than or equal to negative 2.02. So what we're looking for is, we're looking for this area here. We're looking for the area to the left of that. And so in order to do that, we're going to use our table. So let's go down to our z-score table, okay, down here, and we're looking at negative 2.02. So here is negative 2.0, and then there is 0.02. So if we take a look at this, okay, so negative 2.0 all the way to negative to 0.02, and then we're going to come all the way down here. Okay, we can see that we get the area to be 0.0217. So that means that the area to the left is going to be 0.0217. Okay, so next, we now need to find the area, and we're going to call this Z2. We want to find the area to the left of Z2, where it is less than or equal to 1.09. So that means that we want to find the area of everything to the left here, which is all the blue here. So that means it's giving us the entire area of this part here. Okay, and we've already found the area of this part. Okay, so let's go ahead and take a look at that. So we're going to go down here, we're going to look for 1.09, and again, these give us the areas to the left of the curve. So what we want to do is we want to find 1.09. So here is 1.0. And we're going to go all the way to 0.09. And so where do they meet? Well, they meet at the area of 0.8621. So let's go back up here. We get 0.8621. So the entire area that we have in blue is 0.8621. And we know that the area in purple here is 0.0217. Now, in order to find the area that's in between, what we need to do is, if we want to find the probability of negative 2.02, and that's in between x, which is in between 1.09, we need to take the area of the blue, which is 0.8621, and then we're going to subtract the area of the purple, which is 0.0217. And so when we subtract that, what that's going to do is that's going to give us the area that's in the middle here. That's going to give us this area. And so when we subtract those two, we end up getting 0.8404. And therefore, that is the probability that x is in between negative 2.02 and 1.09. So we can write the sentence to be the following. So we can say that, thus, the probability that a randomly selected bag contains between 1,000 and 1,400 chocolate chips is 0.8404. And then recall that this is the z-score for 1,000, and this was the z-score for 1,400. Okay, now let's take a look at part B. Okay, now part B, what part B says is that what is the probability the randomly selected bag contains fewer than 1,050 chocolate chips? So what we want to do is we want to be able to calculate the probability that the value of x is going to be less than 1,050. So let's draw our picture of what that would look like. So we have our bell curve. Okay, we know that the mean is 1,260. And what we want to be able to find is the value where it's the area it's going to be less than 1,050, and 1,050 is to the left of 1,260. So we want to find the area here. Okay, so in order to do that, what we want to be able to do is we first need to find our z-score. And recall that we know that x is equal to 1,050. We know that the mean is 1,260 from the given information. And we know the standard deviation is 129. So using our formula, z, which is equal to x minus mu over the standard deviation, we know that's going to equal 1050 minus 1260 all over 129, which we can round to a z-score of negative 1.63. So what it's saying here is that we want to find the probability of x being less than 1050, which is the same thing as the probability of x being less than a z-score of negative 1.63. So let's draw the graph of that. So if we want to draw the graph of the probability where x is less than negative 1.63, so what we have here is we have our bell curve. Let me draw that again. Okay, now since the standard normal distribution, and I want to line that up with this one as well, because this is now the standard normal distribution, so we're going to have a 0 here. And we know that the z-score that's associated with 1050 is negative 1.63. And so now we want to find the area here. Okay, so what we're going to do is in step 5, we want to be able to find the area to the left. So again, we want to find the area where the value of z is less than negative 1.63. And so before I do anything, let me make this correction here. This should be a z now, not an x, because we changed it to a z-score. And also the same thing over here, this should also be represented by a z. Okay, and then I'll make the correction on the above example after we complete this one. So what we want to do is we want to find the area to the left of negative 1.63. So let's take a look at our table here. So we're looking for negative 1.63. So here's our negative. And so what we want to do is we want to find negative 1.63. So here's negative 1.6. And we're going to go all the way to 0.3 or 0.03. And then we can see that our area that's associated with that is 0.0516. So that is 0.0156. And then let me move some of this stuff down here. So we can see here that the area that we get here is 0.0156. So that means that this area represents 0.0156, which means that this area is also 0.0156. So let's write the conclusion here. We can say that thus, the probability that the randomly selected bag contains fewer than 1,050 chocolate chips is 0.0516. Okay, now let's move to part C. And this is asking us what proportion of bags contains more than 1,200 chocolate chips. So let's go ahead and take a look at that. So for part C, what we want to be able to find is what is the probability that X is greater than 1,200. Okay, so let's draw our bell curve. So when we draw our bell curve, okay, we know that the mean is what value? We know that the mean is 1,260. Okay, and so what we want to find, we want to figure out where 1,200 is located. Well, 1,200 is located there. We want to find the area that's greater than that value. So we're looking for that shaded region. So in order to find the z-score, we know that X is equal to 1,200. We know that our mean is 1,260. And we know our standard deviation is 129. And let's take a look at the formula. So z is going to equal x minus mu over the standard deviation. So that's going to be 1,200 minus 1,260 divided by 129. And that gives us a z-score rounded to 2 decimal places of negative 0.47. So what we want to do is we want to be able to find the probability of when our z-score is greater than negative 0.47. So let's draw our bell curve. Okay, now that we change it to the normal curve, we know that this is going to be 0. And now our z-score is turned into negative 0.47. And we want to find the area to the right of this. So what we want to find now in part 5 is the probability that z is greater than negative 0.47. Okay, which means that we need to find the area to the left first. So in order to find the area to the left, once we find that area, we're going to subtract that from 1. So let's go ahead and find the z-score for negative 0.47. So let's go down here and we're going to look for negative 0.47. So negative 0.4, then we're going to go all the way to 7. And so therefore, we get 0.3192. So what that means is we need to take the value of 1 and then we're going to subtract 0.3192 because this represents 0.3192. But in order to find the red, we need to take the value of 1 and subtract 0.3192 because all of our z-scores have the areas to the left. So in order to find the area to the right, we need to take 1 and subtract that. So when we subtract that, we get 1 minus 0.3192, and we get 0.6808. So therefore that represents the area here, 0.6808. So therefore we can say that the proportion of the bags that contains more than 1,200 chocolate chips is 0.6808. Okay, now we want to move to part D. So let me go ahead and move these charts down a little bit. Make a little more room here. Okay, so the next question wants us to find, okay, part D, what is the percentile rank of a bag that contains 1,425 chocolate chips? So, and we want to be able to calculate the probability of P where X is less than 1,425. Okay, so again, let's draw our bell curve so that we know what we're looking at here. So when we draw our bell curve, we know that our mean is 1260. And we know that 1425 is to the right of that mean, but we want to find the area to the left. So we want to find our z-score. So we know that x is equal to 1425. We know that our mean is 1260, and we know our standard deviation is 129. So using our formula, we want to be able to find the z-score. So it's going to equal 1260 minus, sorry, not 1260, it's going to be 1425 minus 1260 over 129. And so that gives us, rounding it to 2 decimal places, 1.28. So what we want to do is we want to find the probability that z is less than 1.28. So again, our bell curve is going to now be the standard normal distribution where this is 0. And now our z-score is at 1.28. And we want to find the area to the left using the table. So let's find the probability that z is less than 1.28. So let's go ahead and find that. So we're going to go down here and we're going to look at 1.28. So we have 1.2. We're going to go all the way to 0.08. And then from here, we can see that the area is going to be 0.8997. So the probability there is 0.8997. So 0.8997. So what does that tell us? Well, we want to convert the probability to a percentile by multiplying it by 100% and then rounding it to the nearest integer. So we're going to take the probability, which is 0.8997, multiply it by 100%, which gives us 89.97%. And then we're going to round it to the nearest percent, which is going to give us 90%. And so what does that tell us? Well, that tells us that a bag that contains 1,425 chocolate chips is in the 90th percentile, which means that this entire area is about 90% that's being covered. And so this concludes our example, but let me just go back to the part A, because what I wanted to correct was the fact that once we convert this to a z-score, then this now becomes a z, not an x, because originally it was an x, but then it becomes a z-score.